How do Denavit-Hartenberg parameters work in robotics? Have you ever wondered how robots know where to move their arms and legs with precision? The answer lies in something called Denavit-Hartenberg parameters. These parameters are essential in the field of robotics, especially when it comes to robot kinematics, robotics engineering and development, and robot design and mechanics. Denavit-Hartenberg parameters provide a clear and standardized way to describe the geometry and positions of robot links and joints. This method simplifies the complex relationships between different parts of a robot. By assigning specific coordinate frames to each joint and link, engineers can systematically calculate how a robot moves and where its parts are located in space. Each link in a robotic arm is defined using four parameters. The first is the joint angle, known as theta. This parameter shows how much a joint rotates around the z-axis of the previous joint. Next, we have the offset, called d. This measures the distance along the previous z-axis to the common normal, which is the shortest line that is perpendicular to both the previous and current z-axes. The third parameter is link length, referred to as a. This indicates the distance between two joint axes along the x-axis. Finally, we have the twist angle, known as alpha. This represents the rotation around the x-axis from the previous z-axis to the current z-axis. By applying these four parameters, engineers can create transformation matrices. These matrices describe the position and orientation of each link in space. When these matrices are multiplied together along the kinematic chain, they yield the forward kinematics of the robot. This means that engineers can calculate the position and orientation of the end-effector, which is the part of the robot that interacts with the environment based on the joint parameters. To set this up, engineers assign coordinate frames to each joint by following specific rules. The z-axis aligns with the joint's axis of rotation or translation, while the x-axis is chosen along the common normal between adjacent joint axes. When all joint variables are set to 0, the axes align in a home configuration, ensuring consistency in calculations. In practical applications, Denavit-Hartenberg parameters are vital for robot design, simulation, and control. They simplify the complex spatial transformations into a manageable set of parameters. Engineers use these parameters to model serial manipulators, which allows them to derive kinematic equations that control robot motion accurately. While the Denavit-Hartenberg convention assumes ideal conditions, real robots often requiring calibration to account for mechanical tolerances and variations in assembly. This calibration ensures that the models based on Denavit-Hartenberg parameters accurately reflected the physical robot. In essence, Denavit-Hartenberg parameters provide a systematic method to assign coordinate frames and describe the spatial relationships between robot links and joints. This framework is fundamental for solving robot kinematics problems, enabling precise calculations of positions and orientations necessary for effective robot motion planning and control.